Section 7.4 is solving trigonometric identities. Basically, it's proving trig equations and doing proofs with trig functions. And for that, you'll need a lot of the trig identities that we've talked about. So on this slide are the basic trig identities that we talked about back in chapter 6, specifically 6.3, which I've linked the video to this video. So all of the reciprocal functions and also the Pythagorean identities, and also down here I've even included the even and odd properties. The kind of method that we use for proving these identities is 3 basic steps. First, you always want to start with the most complex side. You can only work one side the entire time. You're not proving that 2 middle ground things are equal to each other. You're proving that this one thing is equal to what it says on the other side. So you pick one side and work one side the whole time. You usually want to start with the most complex side because it's the easiest to work with. You want to use algebra, okay, basic algebra that you know, the identities that we just talked about on the previous slide, as well as a lot of times changing everything to sine and cosine to make one side equal the other side. You always want to keep that other side in mind. It'll help lead you to the next step. So here's an example. We want to prove that sine of theta times cosecant of theta minus cosine squared of theta is equal to sine squared of theta. So first thing, we want to pick the most complex side. That was step 1. So I would say that the left side is the most complex side. And we're going to use our trig identities that we already know to prove that sine of theta times cosecant of theta minus cosine squared of theta is equal to sine squared of theta. So first thing, my right side of my equation, I always want to keep this in mind, it only has sines in it. So I'm going to get rid of this cosecant by changing it into sines and cosines. So what is cosecant written in terms of sine or cosine? Well, cosecant is 1 over sine of theta. So now I've converted everything into sines and cosines. Well, what's the sine of theta times 1 over the sine of theta? Those cancel each other out, and you end up with just 1. So you get 1 minus cosine squared of theta. Whenever you have trig functions squared, you want to be thinking Pythagorean identity. So we have sine squared plus cosine squared is equal to 1. So if we subtract cosine squared from both sides, we end up with 1 minus cosine squared is in fact equal to sine squared of theta. So we made the left side of the equation equal to the right side of the equation. So our first step, we picked our most complex side. That was the left side in this case. Then we converted cosecant into something with sine, so 1 over sine of theta, simplified it, and then in this step we used the Pythagorean identity to prove that they were in fact equal. So now we want to prove that 1 plus sine of theta over 1 minus sine of theta is equal to cosecant of theta plus 1 over cosecant of theta minus 1. So all of these that I give you are going to be true. You're just proving that they are in fact true. It's like proving a theorem. Yes, this theorem works, now let's prove it. So I would start with the most complex side. To me, whenever I see something that has something that not sine or cosine in it, that to me is more complex. So I would start with this side, cosecant of theta plus 1 over cosecant of theta minus 1. There are multiple ways to do it, but that's the side that I would start with. So go ahead and pause the video and try to prove this identity. So in this first step, I converted cosecant of thetas into 1 over sine of thetas. So now, think some algebra. What would you do if you're trying to add fractions here? If you have already gone past this step, just continue watching the video. Otherwise, pause the video and try the next couple steps. So next step I used is I'm trying to add fractions up here, and both in the numerator and the denominator. So I made a common denominator. 1 is the same thing as sine of theta over sine of theta. So I made a common denominator, so now you have 1 plus sine of theta over sine of theta over 1 minus sine of theta over sine of theta. Your sine of thetas cancel. You could have also flip changed and saw that they would cancel. And so by simplifying, you end up with 1 plus sine of theta over 1 minus sine of theta. Again, we picked cosecants to be the more complex side because there's a more obvious place to start. Changed our cosecants into 1 over sine of thetas, did some algebra, and simplified. So here's another one, 1 minus cotangent squared theta over 1 plus cotangent squared theta plus 2 cosine squared theta is equal to 1. There's kind of an obvious side to start with. There's not a whole lot that you could do with 1. So obviously start with the left side, and I would do the same thing that we've been doing in the first part. You have something that just has cosines in here, so I would try and change your cotangents into things that have just sine or cosine. So go ahead and pause the video and try this one. So I've started the first part. I picked the left side because there's a lot more you can do with the left side than you can just do with 1. The next step, just like in the previous example, I changed everything to sine and cosine, so I changed cotangent squared of theta into cosine squared of theta over sine squared of theta on both the numerator and the denominator. So I changed everything to sine and cosine. Then, just like the previous example, I changed 1. I made a common denominator. I made 1 into sine squared of theta over sine squared of theta. So made a common denominator. Again, just like the previous example, your denominators cancel. So now we're at sine squared of theta minus cosine squared of theta over sine squared of theta plus cosine squared theta plus 2 cosine squared theta. Again, remember, every time you have squared trig functions, you should be thinking Pythagorean identities. So if you haven't already finished this, go ahead, pause the video, and try to finish this identity. So on the denominator, you have sine squared of theta plus cosine squared of theta, which is equal to 1. So you can simplify that down to 1. The next line, you have sine squared of theta minus cosine squared of theta plus 2 cosine squared of theta. So negative 1 cosine squared theta plus 2 of them is equal to just 1. So just simplified that. And you end up with sine squared of theta plus cosine squared of theta, which is equal to 1. So we picked the more complex side. We changed everything to sine and cosines. We made a common denominator. We simplified the denominators. We used Pythagorean identity to get rid of the denominator here because that just equals 1. We simplified, and then we used another Pythagorean identity. So you'll start to see the patterns. Whenever you have fractions, normally you want to make a common denominator. Whenever you have things that aren't sine or cosine, you usually want to make them into sine and cosine if you can. Whenever you have squared trig functions, 9 times out of 10, you're going to be using Pythagorean identities. So go ahead and try this one. Prove that secant of theta minus cosine of theta minus sine theta times tangent of theta is equal to 0. So on this one, obviously the left side is much more complicated. There's not a whole lot you can do with 0. So again, first thing I did is I changed everything to sine and cosine. So I changed secant into 1 over cosine, and I changed tangent into sine of theta over cosine of theta. So then the next step, I have some denominators here. So I wanted to give cosine a common denominator, so I multiplied it by cosine of theta over cosine of theta. So it became cosine squared over cosine. So I just made a common denominator. So now I have 1 minus cosine squared minus sine squared all over cosine. I factored out this negative here because, again, I have squared trig functions, so I know I want to use the Pythagorean identity. So I wanted to make my identity look like something that I can use a Pythagorean identity. So I factored out this negative, so I have 1 minus the quantity cosine squared plus sine squared all over cosine. Well, sine squared of theta plus cosine squared of theta is 1. So now I have 0 over cosine, which 0 divided by anything is just 0. What you'll find is a lot of times there's multiple ways to solve these problems that are correct. For this one, for instance, it doesn't actually matter which way you start. It doesn't matter if you start with your secant side or whether you start with your tangent side. Both sides are equally easy or difficult. You could use even and odd properties, seeing that you have some negative thetas in here, but it wouldn't matter. You would have to redo what you undid. And also for this one, you could change everything to sine and cosine, but it just gives you a couple extra steps, so I would suggest not doing it. But like I said, there's multiple different correct answers for these. So go ahead and pause the video and prove this identity. So again, this is not the only right answer. I chose to start with the secant side just because that was the first side written. If you had started with the tangent side, just look at my work but go backwards and it would be the same thing. So I factored out secant squared. I factored out the lowest power, so I factored out a secant squared of negative theta. If you factor out a secant squared of negative theta, you're left with a secant squared of negative theta minus 1. And then, if you remember your Pythagorean identities, there's one that says tangent squared plus 1 is equal to secant squared. So I use that. Secant squared of negative theta would be tangent squared of negative theta plus 1. And then if I subtracted a 1 across, secant squared of theta minus 1 would just be tangent squared of theta. So I used my Pythagorean identity on both of these, and then I just multiplied it back together, and you end up with the right side. So there's not one way to do every single one of these problems. It takes a little bit of creative thinking. The most important thing is knowing all of your identities. If you don't know your identities, it'll be very difficult to solve these more complex identities. You have our basic steps, kind of a guideline to follow, but not every single problem is going to be exactly the same.